For our last topic of this chapter, we're going to talk about making errors, or we've already made the errors, I guess, but describing what they would look like or what the consequences of them would be. So because we're making a decision, we could have made the wrong decision, is basically the idea behind this concept. A type 1 error is if I reject the null incorrectly. So if I decide that the null is incorrect when it really was correct. So if at the beginning of the chapter you thought your deck of cards wasn't normal when it actually was, maybe just your sample turned out to be a little more or less in favor of the reds. A type 2 error is if you failed to reject the null incorrectly. So if your group thought that you had a normal deck, when it actually wasn't a normal deck, just based on your individual samples. So notice that the main difference between these is all based on what you decided to do on the null. So if I rejected the null, then I've made a type 1 error. If I failed to reject the null, I've made a type 2 error. No worries about the claim in this case, just whether I rejected or failed to reject the null. As a real-life example of this occurring, think about our justice system. You are presumed innocent, which would be our null, versus the alternative that you are guilty when you enter our system. Okay, so a type 1 error would be if you were found guilty even though you were actually innocent. In other words, your innocence was rejected even though it shouldn't have been. Whereas a type 2 error would be if you were found not guilty or found innocent when you were actually guilty. Here's an organizer that might help visualize where these type 1s and type 2s would be occurring. So if the null is true and I fail to reject the null, then that was the correct decision. Likewise, if the null is false and I reject it, that's also the correct decision. However, if I reject the null when the null is true, that would be a type 1 error. And then if I fail to reject when the null is false, that would be a type 2 error. Now you won't necessarily have to replicate this unless it helps you. It would be optional, but just if you're a more visual person, that it might help see how that fits in. All right, so as some examples. See something very similar to our homework last night, except it was actually the problems we did in class together. We're going to take a look at each one and just revisit whether we reject or fail to reject, and therefore what type of error that we could have made. Keeping in mind, if we rejected it, we could have made a type 1 error. If we failed to reject, we could have made a type 2. So on the one about what proportion of U.S. adults are allergic to medication, the p-value was 0.11, so 11%. So we would fail to reject the null. Therefore, since we are failing to reject the null, we could have made a type 2 error. Okay, the percentage of students who go out of town for college also fail to reject the null. Therefore, another example of possible type 2 error. Okay, so we said we think the Steincase is wrong. We think it's actually 23% or lower. Could have made a type 2 error. Now, let's look at these two as well. Think about what could be a consequence of this. So this one, if I was saying that the 20% is incorrect, or sorry, the 20% is what I'm supporting, the less than 20% is correct, what could be a consequence of that? Well, you could say that if I think 20% or more have the allergy, then maybe the company decides to pull the funding from that medication or pull it from the shelves because it has such a high rate of allergic reaction. when it was unnecessary. Okay, so it'd be different if it was a necessary recall, but if it was just pulled because of the study showing a higher percentage than true having an allergic reaction, then that could be bad for the company. So consequence of this one would be maybe the company could not fund or pull medication because they believe in the high rates of allergic reaction. Okay. Next one, we have, once again, we're saying that the Steinke is wrong, which could be a possible consequence. The Steinke could get a bad performance review for not knowing these facts, since that is her job down guidance, is to kind of know and direct students to the things that they need. It could show badly on a Steinke unnecessarily. Okay, so she was actually correct, but we disagreed with her possible consequence. Okay, take a minute and look through the rest of these examples, see if you can pick out what types of errors could have made and think about what a consequence is, and then we'll talk about answers and compare. Here are the examples I came up with. Keep in mind you have a lot of leeway here in terms of the consequences. You can be kind of creative or come up with totally different answers as long as there's a logical consequence following the decision, then you get full credit. So number 3, we rejected because of a small p-value, which we could have made a type 1 error. So for example, I could assume that the proportion of people who watch the news is higher than it actually is, and therefore if I want to distribute news to the city, use the regular news broadcast, and information is badly distributed because not as high of a number of people watch the news as I thought. Okay, number 4, once again, I reject. So maybe the U.S. Army doesn't take the reports of extraterrestrial beings seriously. A little bit of a silly one, but the next 2 are 2 sample ones, the same process, so type 1 error for this first one. So maybe a candidate looking at the polls thinks that the support for this idea that someone should take care of themselves, that there's less support for that, and then they use that as part of their policy when they're running for election. If in fact the proportion of voters has not dropped who feels a certain way, then they may not be elected. And last one, also a reject, therefore a type 1 error. If I think that there's a lower proportion at the private school, I might either not put in some smoking cessation programs at the private school, or might use additional funds at the public school to try and reduce the proportion of smokers there, when really the proportion is the same as at the private schools. The next thing we're going to take a look at is just 2 very brief review examples that we'll do together. First, what I'd like you to do is kind of pause this video, take a look back at your homework from last night, and see if you can determine which one should have been type 1 and type 2 error, and think about possible consequences. And you can check it with the answer key. You'll notice that my answer key does not have possible consequences because there could be so many possibilities, and we will talk about those at the beginning of next class if you have any questions. So go ahead and revisit your homework and then come back to this video so that we can finish the 2 problems for review. Okay, first problem for review, we have the Mississippi DMV has implemented a new program to try and get more than 70% passed on the first try. And then of the 126 randomly selected, 95 cars do pass. So we're testing null equal to 0.7 versus greater than 0.7 because we're hoping that more of the cars pass the test on the first try. Here is what we would type into the calculator. So 0.7, 95 out of 126, and then greater than. This gives us a p-value of 0.09, which means we would fail to reject the null hypothesis. Okay, when we look up here at the top, it looks like the alternative was actually our claim. So if we're failing to reject the null, that means we cannot be supporting the claim as well. So we would disagree with the claim that the program helped. And then here's the part that we're tacking on today. Could I have made a type 1 or type 2 error? Well, since I have failed to reject the null, that could have been a type 2 error. Okay, consequence, they might discontinue the program when it was actually helpful. Okay, so he was doing something to help cars pass the emissions test on the first time around, but we're going to discontinue it because we don't think it's as helpful as we would like it to be. It's not changing our percentages. Okay, next one. So we are looking at, in Michigan, whether a particular preschool program helps kids not need social services later in life. So we have 38 kids out of 62 who attended preschool needed social services later versus 41 out of 61 who did not attend preschool. So we're looking for whether it's going to reduce the need for social services. So either P1 is less equal to P2 versus P1 is less than or P2, or if you prefer the subscripts that tie a little closer to the problem, the probability for proportion for preschool is equal to proportion for no preschool. Proportion preschool is less than the proportion of no preschool. Test statistics, put in your X's and N's for each sample and what your alternative is, and we get the calculation of 0.01. So we would reject the null. Okay, looking up at the problem, we were hoping that it reduced, so therefore our alternative is once again our claim. So when we reject the null, that means we're saying that this is incorrect. We are agreeing with the claim. That the preschool helped, reduced the need for social services. Okay, and then since we rejected the null, we could have made a type 1 error. Consequences, we would spend money on a preschool program that wasn't working. Okay, what I'm going to ask you to do now, once you're finished, find somebody that's at about the same point as you are, and take a look at on OneNote the in-class proportion practice. See if you can complete that with them. Compare notes, and I will try and get an answer key up there as soon as I can. And then when you finish that, read over the study guide for our last statistics test. We will have time at the beginning of next class to go over any questions you have, but that will be your assignment tonight. And a bonus opportunity is if you find real life example of type 1, type 2 error, then you can get bonus points on the quest. I will